Welcome. This is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium, which took place in Kuala Lumpur, Malaysia. This conference is made possible through the support of the PKI Consortium Post-Quantum Cryptography Working Group and our sponsors SSL.com, Entrust, Keyfactor, HID, and Crypto4A. And with exceptional organizational support from SSL.com, Keyfactor, Logius, POS Digicert, Baker Tilly, MSC Trustgate, and Digitoris. Join the discussion. Join the PKI Consortium. Go to pkic.org/join.
All right, we'll get started on our last session before the mid-afternoon break. So it's my pleasure to welcome to the stage Tomas Gustavsson. He is the Chief PK Officer at Keyfactor, the creator of EJBCA, and probably the all-round nicest guy you'll ever meet in PKI. And he's going to be talking to us today about what we need to deal with in PQC. Take it away, Thomas.
Thanks, Scott. Okay, thanks for the introduction. So first, of course, August 2024, we really moved to MLDSA, MLChem, and SLHDSA. Everything else is not correct, so to say. But this is where it all started. And back then, though, it was quite hard to actually do things or try out things. If you're a developer and you saw a bouncy castle, of course, implemented the algorithms very shortly after the standards were out. And as a developer, you could start using them. But for, say, the rest of us, if you're not a developer, a normal administrator, things were a lot harder. And this is kind of a conclusion we had just earlier this year in the spring. We had some work with some financial institutions, and the steps to quantum readiness is the same regardless who you ask, big consultancy firms or, you would have seen it a bunch of times by now. But when actually trying to do things, you kind of stopped around step 2, 3, or 4 somewhere because when you want to migrate to post-quantum cryptography, there's a whole lot of different equipment involved. And when bigger organizations or enterprises, financial institutions start to look at the whole stack of what they need to upgrade, they found that they can't move very far because vendors are not or were not ready. So, but what I will talk about today is a lot of what was the fact 6 months ago is different from today, and it will be different 6 months from now. So things are moving extremely fast right now, and you can actually start doing and migrating to things quite rapidly. So a little bit, we heard David Hook talk about the actual standards, which I thought was great. So this is one thing also I thought I had from PQCC.org, which have a heat map. So this is the latest one they have, this September, kind of outlining different standards like TLS 1.2. We see that TLS 1.2 will never have, or there's a consensus against inclusion of PQC algorithms, so it will never get stuff. TLS 1.3 have a different level of maturity for depending on where the standards are and where the implementations are. So this, of course, is moving, and we want everything to be done at number 9, broad adoption, of course, but things take time. So there's a lot of things happening in standardization and in implementation of it. So if we then look at how would you actually go about to start migrating, and I'm thinking about migration, not what I can do as a developer. So I've been working with this for a couple of years now. I can do, quite a lot. But for organizations where you're not developing everything yourself, I started looking at the different use cases. So this is my most complex slide. So we're on PKI Consortium. I'm a PKI nerd. But PKI is not an application itself. It's an enabler of use cases. So I started outlining, the use cases which I would like to test. How can we migrate to PQC end to end for such a use case? Starting with things like firmware signing and verification, which is anticipated one of the first use cases for post-quantum cryptography. Well, on the bottom we have TLS, which is kind of the second one. And in between we have a bunch of other things which may or may not be 100% obvious, like, of course, document signing, contracts and everything like that. We have things like SMIME email, where clients may or may not be ready, and also things like which are driving our infrastructure and devices, like secure boot and those kind of things. So I put green checkboxes on stuff that I have been able to verify and test, end to end myself. For example, firmware signing and TLS. So the ones that are, I would say, most mature use cases. So if we go into look at PKI first. So this is where, when you start playing around with PKI, you issue some certificates and you verify it with bouncy castle, maybe OpenSSL. And then you realize, oh, okay, we also need validation. So we need revocation and validation, so OCSP, and check that box, etc. And then when you're moving, of course, HSMs is a super important piece in this, because you will not migrate PKI until you migrate your whole PKI stack, which include hardware security modules. And this is just to show what you have to do in order to support many different hardware security modules which are out there in the industry. So some of them support PQC 11 version 3.2, which will be ratified, hopefully next week, actually. Final is currently in draft. So some HSM support that. You implement against that, and you support a couple of hardware security modules. Others have what is called vendor-defined mechanisms in PQC 11, so you have to code specifically for that. Say, if this HSM, do like this instead. And then there are REST-based HSMs which all require custom REST client implementations. So there's a lot of code to write in order to do this. But we've been doing this for a while. So this is a follow-up first, just a small kind of brief completion of presentation I held in Austin at the same conference, where I had tested 4 HSMs, now we're tested 10 HSMs, and the conclusion is still the same. If you take for a PKI use cases, which might be certificate issuance or OCSP validation, for example, which is fairly high speed, you get better performance than RSA in most cases with MLDSA. Because it's still one of the most common questions we get, how much slower will it be with MLDSA? But as we heard from previous presenter as well, you don't have to worry about it too much, not for a PKI use case. Can issue hundreds of certificates per second or 1,000 OCP responses per second. It's not a problem. So we can forget about that and move on. The next thing that you may notice when you're trying to migrate to PQC with your PKI is CRL sizes. For all the new algorithms are completely, sign and not hash and sign like SHA-256 with ECDSA. MLDSA is, you send the data and you get the signature back. And you're not, if you want really big CRLs, like I have an example here of 600 megabyte, which is still only 10 million revoked entries. It's not feasible to stream that to an HSM over the internet, for example, and some cloud-based HSMs have a actual limit of 4 kilobytes as payload, so that's very small. So that's where external mu comes into play. We've been talking a little bit about that previously, if you have been on those sessions. So, but that saves the day, which is something that the IETF invented and put in the specification for using MLDSA signatures in PKI. So this is an example where if you start migrating your PKI today, you may actually run into issues when you start issuing larger CRLs. But this is also something we see. So among HSMs I tested, currently I have implemented one which does support external view. There are others coming. So, well, you know, the same thing. If you run into troubles with that today, 6 months from now, it's probably not a problem. So things are moving fast and moving fast in the right direction, I would say. So the next interesting use case, which I want to test end-to-end, is TLS. And I'm not so interested in, say, what I could do with Bounce the Castle or coding. I want to know what you can do off the shelf, because, well, if I consider myself not a developer, but if I try to take this stance of a administrator of a large enterprise, what can I do? And this is really where things have changed dramatically in the last 6 months. So in April this year, OpenSSL 3.5 was released, which was say a real milestone in the migration to or broad-scale migration to post-quantum cryptography, because that is the underlying platform of basically all, definitely all Linux operating systems, which then builds on web servers and everything is built on. So just a couple of weeks ago, in the beginning of October, Ubuntu 25.10 was released, for example, which I used for my testing. It comes with OpenSSL 3.5 out of the box. The same if you're using a Red Hat Enterprise Linux, they have a test, which you can play with. Red Hat 10 out now. Red Hat 10.1 will come out in May next year, which ships with OpenSSL 3.5 out of the box. So you don't have to do anything. And of course, other distributions as well. Even Windows have betas out where if you're part of the Windows Insider program, you can get some test stuff there. So, but what this enables you to do is the nice out-of-the-box experience, which is you don't have to do anything. So in this, I want to install an Apache web server. So if you're used to Debian-based distributions, you'd just say apt install Apache and enable TLS, and it's done. You don't have to do anything else, not a single configuration. And then you can see key exchange group MLCAM 768X25519, which is a hybrid key exchange, which Morale was talking about previously. So don't do anything, just install a plain out-of-the-box Ubuntu operating system, install Apache, set up a virtual host as you would normally would, and you have quantum safe encryption for your TLS tunnel. So this is really groundbreaking for the migration to post-quantum cryptography, in my opinion. So this is the certificate or the authentication still uses ECDSA. So this is why I called in this slide there, classic certificate. And you see signature scheme is ECDSA. So what happens then if I try to use an MLDSA certificate? Well, I have another virtual host, so my Apache supports both. Yes. So, thank you. So, Apache supports both, of course, because it's based on OpenSSL 3.5. So it works nicely to set up the other virtual host called PQC.com, but my web browser does not support MLDSA, so we see no cipher overlap error, which is, if we saw a presentation before lunch, go to your browser vendor and ask them to add MLDSA support to the browser. But, I mean, this doesn't mean the end of the world for us, because if you're not having a browser-based use case, if you're developing for, or if you're setting up a server for an API endpoint, for example, that works fine. So if your endpoint is an API, or if your client is an API client, well, OpenSSL based again, that works. You actually see it uses both MLCAM an X5 or hybrid key exchange for quantum safe encryption of the TLS, and it uses MLDSA44 in this example as the server authentication. And another example, which is 100% out of the box, curl, which is one of the most widely used actually TLS clients for API communication in the world, is used in billions of devices, even on the moon. And well, actually a Swedish guy, which I know, is the inventor of curl. So I like to show this slide. So also, 100% out of the box, just install curl in your favorite way, apt install curl or snap install curl, and connect with API normal TLS. And yeah, we have TLS 1.3 with MLCAM, key exchange, and MLDSA authentication. So this is, well, it just works. And you can even use certbot to automate your certificate lifecycle management on your Apache server there. Of course, certbot is a popular option. It almost supports everything. You can actually use it to get your MLDSA certificate and renew your MLDSA certificate for your server. But the front end, or I mean the command line interface of certbot is not updated, so you cannot say dash, MLDSA 44. It only has RSA and EC. But if you generate the CSR using OpenSSL, you can actually feed it into Acme. So with a little bit of scripting, yeah, it's out of the box as well. And you can do the same with Java. So just configure your JVM to use Bouncy Castle for TLS instead of Sun or the standard TLS in Java. You don't have to change anything on your application. Just configure your Java security file, and boom, you have MLCAM. Key exchange, which means encryption. So this is really nice, in my opinion. The other use cases I will mention is signing, which is similar, but I will show you some gotchas as well. So you can do off-the-shelf CMS signing, which is, of course, the underlying signature scheme for PDF signing, or a lot of firmware signing uses CMS format, etc. So the server here uses actually Bouncy Castle under the hood, sign the file, and you can use OpenSSL to verify it. It just works out of the box. No coding needed, no nothing. There are some stumbling blocks that you will encounter also, which is why you need to start testing things, because everything doesn't necessarily work out of the box. So timestamping, which is actually a feature that many organizations want for document signing, for firmware signing. Well, you couldn't verify it with OpenSSL. You can generate the timestamp, but OpenSSL won't verify it. So there's an open ticket that I created with the OpenSSL project to handle this, because it's so now it's a known issue in OpenSSL, so it will be fixed. But today, if you try this, well, you will have one stumbling block. There are other things as well, like if you want to be CNSA compliant, it used to be simple. If you're using SHA-512 with RSA and signing CMS messages, the digest algorithm would default to SHA-512. Makes sense, right? Which is CNSA 2.0 compliant. With MLDSA, it's not there's no such obvious default digest. The internal digest in MLDSA is Shake 256, which is not CNSA compliant. So you have to specify the digest algorithm. So that means if you're upgrading your algorithm to MLDSA, it's you will have to change some parameters. This is actually also being addressed at this moment in the OpenSSL project. So there's a stumbling block today, come back a couple of months from now, and it's going to be solved. So, which is why it's important to test things, because if you test things, you can figure these things out, and you can actually contribute to this open source project to get it fixed. So it will be easier for you, for me, and for everyone. The last stumbling block is kind of the same. And so I think I will have we have talked about hybrid certificates a lot, so I won't rest on this too much. So there's a lot of complexity. When we've tried, issuing hybrid certificates to some devices. It works in the sense that they ignore extensions, the camera extensions, as David Hook talked about. But it actually doesn't really test anything about except the ASM1 parser of these devices. If you actually want to try to use it in for real, it gets complicated because then you have multiple private keys, and how would you distribute those, and how should you actually plan that something should be able to use it. So there's been testing going on and composites stuff as well. So the conclusion is that a full stack migrations or migrations to hybrid schemes it's pretty complex. So it is, while a pure PQC, as everything I showed before, is really available today as an out-of-the-box experience. So my conclusion is this. Is there time to procrastinate to migrate? No, because now you have it out of the box. Just do it. Is it easy to start? Yeah, as I said, yeah, you have it. Will you find issues along the way? Yes, which is why it's important to start testing, because these issues might be really simple. So they can be addressed pretty nicely. Is everything production ready? No, but a lot of things are. Like this TLS stuff and OpenSSL 3.5, Apache web servers, it's all production code. It's there. Can you contribute? Absolutely. If you find issues, report it to Bouncy Castle, us, OpenSSL project, whatever, and they will be fixed. And so it's super cheap to start testing now. It wasn't, a year ago, I would say it was fairly expensive to start testing. Now it's easy, cheap, out of the box. There's no reason to procrastinate anymore. That's it. Thanks.
How do you get to a quantum-safe state? That depends on the current state of your digital security infrastructure, as well as your level of visibility, control, and automation over those systems. Check your level of preparedness with the Entrust Post-Quantum Readiness Assessment. Whether you're already on the path to quantum safe or just beginning your journey, Entrust can equip you with the right knowledge and solutions. There are many paths to a quantum-safe future. Secure yours by taking the Entrust Post-Quantum Readiness Assessment today.